Hello peeps, welcome to Tackle. So today our topic is parameters versus hyperparameter. So first let's see what is a parameter. Parameter is nothing but a thing or value which is already being predicted or self-calculated by the model. It is learned by a model by itself based on the historical training data. So here it is also referred as model parameter. As model itself learns it, it is meant as model parameter. And coming to examples, for example, we take weights and biases in neural networks. So after each layer, based on the input that is being given to that layer, the weights and biases are adjusted. So these are adjusted by the model itself based on the input, and it's learning from that input and accordingly adjusting these values. And also if we talk about coefficients in linear regression and logistic regression, so these values are being calculated based on the input data values itself. Also split points in decision tree, so all of these come under a model parameter example because they are being calculated based on the given input data or the training data. And also when it comes to model parameters and statistics, we can take examples of different distributions. For example, normal distribution, Gaussian, or T distribution, F distribution, many distributions. For instance, let's say it's normal distribution. So the two parameters that we use in normal distribution are mean and standard deviation, which are indeed again calculated from the data points. For example, if we have x1 till x1 to xn, then mean is nothing but the average of the values, and standard deviation is how much the each value is being deviated from the mean. So these two parameters, once we calculate from the data, we are using for calculating the normal distribution. So this can be considered an instance of model parameter in statistics. And coming to programming, so if we take a function in a programming and we pass values to that function, so that is called as parameterized function. Here, for example, if we say f of x is equals to 5x, it is a function and x is a model parameter which is taking values from range 1 to 10. So if it's 1, then our function value will be 5. If we put it as 2, then the result will be 10. So this is how we can discuss model parameters in programming, where x is a model parameter here which is taking values ranging from 1 to 10. So moving on to hyperparameter, the main difference between the model parameter and hyperparameter is that the hyperparameter cannot be learned by the model or decided by the model based on the data. So here there needs a person or a practitioner, whoever is implementing the model, to choose the value. So how do we choose a hyperparameter value is that we can go using trial and error method or by using heuristic. Heuristic is nothing but the background knowledge or something that we know about the process, so that based on that knowledge we are going to choose this value closer and efficiently, so that will affect our model and improve the performance. So model parameters, when it comes to the case of model parameters, they are chosen using the optimization algorithms, which are nothing but searching efficiently within the all possible parameter values set. But when it comes to hyperparameter, that is the practitioner gets a choice to choose what value. It is not estimated by the model, but then it is being chosen. So looking at the hyperparameter examples, we have the learning rate, which is denoted by alpha in neural networks, or the number of epochs, that is number of times the algorithm is being run, number of hidden layers, that is between input layer and the output layer, we have hidden layers. So we can choose a number of hidden layers based on which we can actually deal with how depth the algorithm can be. Like for example, if there is only two hidden layers, the computation complexity is less. When if you go for higher hidden layers, that is number of hidden layers increasing to 3, 4 and so on, the complexity increases, and also the depth and how efficiently the algorithm is learning also increases, and the number of hidden units, activation functions. So here we can also choose what activation function to be run, and also number of activation functions as well. And also the k value in k nearest neighbors is also an example of hyperparameter. Yeah, so here we can see in the diagram that depending on number of layers and number of neurons and the learning rate, the optimization is being happening and the score is increasing and decreasing. So choosing the hyperparameter, we have to be careful that our algorithm is not adversely affected. So what is the need for hyperparameters is that they're important because they have overall control on the performance of the algorithm, and they can improve the efficiency of algorithm drastically, and also if not chosen right can also have an adverse effect on the algorithm. So choosing the right parameters can help us search in the problem space efficiently, improve the accuracy and efficiency of the model, and also optimizing the hyperparameters will help us achieve the maximal performance of the model chosen. Thank you, and please subscribe to my channel and also hit the bell icon for further updates. Thank you.